Okay, so you got yourself a Stryker SR-497HPC, high-power black box radio, and you have either replaced the driver or the final MOSFETs in it, because this runs IRF 520s for the driver, and then it has 4 IRF 520s for finals, or if you're, in my case, just doing a transceiver alignment. Now, this one's a little bit weird because of the way that's set up. Now it actually uses a transistor, a normal bipolar, or a 2SC2078, which just by chance happens to be the final used in radios like a Cobra 29. So that, I guess, is what you would call the pre-driver in this radio. Drives the driver, and then that drives the 4 finals. So the procedure for adjusting the bias current on these is a little bit different. Now, usually with the difference when making adjustments when you replace driver or finals, in most radios, if it's a transistor, you adjust bias current. When you're working with MOSFETs, you adjust bias voltage. That's not how you adjust it in this radio. Yes, it has MOSFET driver and finals, but the factory says to adjust the bias current. And they have a specific procedure for doing that. And I want to show that procedure because it is kind of an oddball procedure, and it removes, for starters, before you even get too far into this, this is a surface mount radio, folks. Surface mount component in this radio. And we're going to be removing a surface mount component. So you're going to need a soldering iron. Clean the tip off. Really fine tip soldering iron, really small. Preferably the longer the better, because you got to get way down in there. It's the part we need to get out is kind of surrounded, and you're also going to need, ideally, reach down here and get it, because they're down here cooking in the hot cubby, a set of tweezers, hot tweezers. Now these just happen to be made by Pace, but you can make do with soldering irons. This isn't a course on how to do soldering, so I'll leave that up to you. But you're going to need some way to remove a surface mount component. So stick these back in the hot cubbies. I'll actually show you what we're going to be doing. So there are a few things we need to remove. The first thing we need to remove are 3 jumpers. So there are 2 in the final circuit and 1 in the driver circuit. So underneath the fan here at the front, there are 2 jumpers, run from left to right. There's one in the front, JP101, and then JP102. So we need to remove both of those. They're just a little plastic guy with a shorting bar in them. And actually the shorting bar is not in there because it's stuck. There. Yeah, the shorting bar was actually stuck. And then remove the rear one. Oh, the shorting bar stayed in that one. And then there's another one, JP103, which is for the driver, and that's right here, behind this big electrolytic capacitor. Need to remove that. Okay, so now that you've got all 3, and before I forget, I'm going to find my tweezers, pick this little guy up. I want to reassemble this jumper. It fell apart. Put the actual bar back up inside of it before it decides to run off, get lost, and I got to go dig one of these out. So now it's back in there. Okay, so the other thing we need to remove is a capacitor. Let me turn my headlight off here. If you're wondering what that light moving around is, yeah, I'm one of those guys that works with a headlight. And I'm not talking about the car kind. What we need to do is remove the coupling capacitor to completely disable any RF energy from getting into the PA unit, or the amplifier section in this. So what we need to do is remove this capacitor right here. It's C551 is its identification on the schematic. Okay, it's my head down here. What the hell is that? A 390 picofarad ceramic capacitor. So here's, I guess, in the case of this radio, the way it's set up, this would be a pre-driver. This is the driver, a 2SC2078, that drives a single IRF 520, which in turn drives, after binocular tubes, which are underneath the fan down there, through the binocular tubed transformer, then drives the 1, 2, 3, 4 IRF 520 finals. So we need to remove this little guy. That removes all RF energy from getting in to the final section. And that little guy is located right here, right in front of, or right not in front of, behind. Okay, you've got, this was what I call the pre-driver, because that's the one here, and then we have the driver, or the pre-driver, the driver, and the finals. So right directly behind this, behind the center lead of this, right here, there's a little ceramic cap. It's right to the left of this electrolytic capacitor. Where this coil is soldered down to the board, right in front of it, and right behind the center lead of this transistor. This little ceramic capacitor runs front to back. There's two of them right beside each other. They're offset a little bit. Don't remove this one. You want to remove the one to the right, closest to this electrolytic capacitor. So let me get that little guy pulled out of there. Grab my tweezers. See if I can do this in the camera or not. Not sure if it's going to get in my way or not. Okay, and there it is. So, that's the little guy we just removed. It's kind of a off-white or a tan color in the middle. It's got metallic ends, okay. So that's the little 390 picofarad cap we just removed. So don't lose that, not unless you're like me and have stock surface-mount components, because we're going to have to reinstall that. So now we can hook the power back up to this radio and actually adjust the bias for the driver and the final. So power is hooked back up. The mic plugged in. Oh, excuse me. Turn the radio on. Now, something else that's a little bit unique in this is to protect because MOSFETs are very static sensitive, they're very prone to that. They don't want to just directly connect the amp meter up to these, okay? What they want you to do is install a 1 watt 10 ohm resistor. Now, I actually am using a 2 watt, which is bigger, so that's fine, but it has to be a 10 ohm resistor. So install at least a 1 watt 10 ohm resistor in series with your amp meter. Now, to actually hook up to these little, where the jumpers were removed, I'm just using a little plug here, some wires. It's not any kind of crazy amounts of current, so it doesn't need to be really big. But like I say, I just have this one made up permanently with this little 10 ohm resistor. So we're going to adjust the driver first. So that's this jumper in the rear, JP103. Plug that onto those two terminals. It's hooked up to my amp meter. I'll swing the camera up to the meter here. And I'm going to adjust, actually I guess, I don't know if I showed you or not, where the adjustments are. Okay, so there's two adjustments. There's the one back here. This is for the finals. There's an adjustment right here, right just slightly behind to the left of this big can capacitor. This is the one for the driver. So this is what I'm going to be adjusting right now. This adjusts the driver, one in the far rear left-hand corner, adjust the finals. Come up to the meter, key the microphone, and what we want to adjust for it on the driver is 60 milliamps. So key the mic. And my jumper fell off. Get that plug back on there. And where in the hell is my... I'm looking for my proper size screwdriver for the slot in that thing. There we go. Oh God, I hate that's why it wasn't working. It's one of those ones that are really, really stinking sensitive. You move it like a thousandth of a turn, it jumps 20, 30 milliamps. 80. damn it. I hate this kind. Gotta love cheap radios. Huh? Oh, 61. That's as close as we're going to get it, I can tell you right now. As coarse adjusting as that is. 61 milliamps, actually 61.49 milliamps. That's as close as it's going to get. And you can see it's fluctuating. But for these radios, that's as close as we're going to get it. So, pull the jumper off of there. And now I'm going to slide over to... And it doesn't matter either the front two or the rear two. And you can see the fan's running. That's just... Stop that now. It actually shut off. It's on a timer. Anytime you key the mic, the fan comes on. Doesn't care if there's RF energy going through or not. As soon as you key the mic, the microprocessor turns the cooling fan on, and then once you unkey the mic, it continues to run for a short duration. Get our... Just turned around here. Looks like it's on there. And up here at the meter again. And now we're going to be adjusting that one in the far back left-hand corner. And for the finals, we want to adjust for 120 milliamps. Key the mic. Yeah, that's way too low. Ah, that's way too much. Another one. Really coarse adjustment. God, I hate these things. Jesus, it's from 50s to 300s. 100. 119, that's as close as we're going to get it. And it's actually creeping up. So, there we go, 120 milliamps. Okay, and it's just that simple. The bias current has now been adjusted for the drivers and the finals. Turn the radio off. And even with the radio turned off, see, no power, the fan continues to run. Like I say, it's microprocessor controlled. So now what I need to do is reinstall that little ceramic capacitor. Get my microphone cord unraveled here. So, doing this on camera is just going to be a pain. Yeah, I guess I can get in there. Let's see, how does that look down in there? Yeah. I don't think that tip's going to be big enough. Yeah, I'm not going to be able to get down in there with my little desoldering tip. It's a little bit too close. I think I'll just use a little bit of desolder braid to clean up the pads. That way that capacitor's not rocking back and forth while I'm trying to hold it down and solder it. Grab my desoldering braid. And a touch of flux. Never have too much flux when you're soldering, desoldering. Flux easily washes off. This camera's going to kill me. It's one reason you never see me working on camera. It's so hard for me to work around cameras. I'm always bumping it. Honestly, I don't know if I'm even going to be able to get in there to solder that capacitor back in on camera. At least not that you'd be able to actually see me doing it, because it's just going to be, the camera's just going to be way too much in my way. I'll try here real quick. Let me get my tips changed back over. Now I have the really long pointy one back in there. So we want to find our tweezers. Take our little tiny capacitor. Set it back down in there. Halfway close. flood the area with flux. Like I say, this is a pain in the butt doing these because you're kind of surrounded. You've got the metal chassis right here, you got an electrolytic capacitor here, you've got a transistor right here. So yeah, if you don't like working in tight confined areas and don't like surface mount components, this is definitely not a job to do because you ain't gonna like it. And what I'm going to do is actually just preload a little bit of solder onto the tip of my soldering iron. I'm going to try to get down in here and just put some downward pressure on the capacitor so it doesn't move. Clean off my tip. A little bit more fresh solder. Drop of flux. Gotta remember, never ever ever have too much flux. I'm gonna pull this up in a way so I can actually inspect it because I couldn't half see what the hell I was doing. Yep, she's in there good. Now we'll get ourselves a swab. A bit of isopropyl alcohol on there. Yep. And there, I just can't get it with the shadow. Oh, guys, back down in there now. Oh God, where did my cap go? Oh, there it is. I got tired of impaling myself on the tips of these damn bottles. Made up some little rubber tips to stick on there. Really got tired of, every once in a while I'd swing my arm over and set my arm down on top of that. Yeah, I literally impale. I stuck one of these things like 3/4 of an inch into my arm one time. Luckily it was isopropyl alcohol, so I mean that's sterile, but yeah, I mean I could have had some nasty, it could have been one of my other chemicals, and it could have gotten really ugly, you know, and involved a trip to the hospital, which I would really prefer not to do. Okay, we need to put our 3 little jumpers back in now. And of course they make access kind of limited here. This blasted fan's in the way. Come on, little guy. There we go. There's one. There's 2. Third one's easy because that's get a straight shot down on it. And 3. And hook up the mic cord. Power up the radio. Key the mic. And we have power. Audio. 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 Yeah, what we got? What the hell is it? Right there. Roger beeps on. Audio. Audio. So, there we go. Oh, crap. Oh, you nitwit. Oh, I was transmitting on air. I haven't done that in about 2 years. I just noticed the needle was moving. I didn't have it on dummy load. Yeah, you big dummy. Yeah, that's what I should hear when the volume's up. Absolutely nothing. Luckily, I was on, channel. Yeah, so that's just a long distance skip, so I wasn't interfering with anybody local, luckily. Audio. Audio. But, yep, so she's working fine, and I'm now not transmitting on air. Oh, God, I have to watch that. Another reason why I don't like doing repairs on air. I end up making stupid mistakes like that. I'm too busy talking to the camera and not paying attention to what the hell I'm doing. But, yep, so there's the procedure. Remove 3 jumpers. Very, very, very important. You will never, ever, ever get the driver and final bias adjusted properly on these if you do not remove that ceramic capacitor. So make sure you remove that ceramic capacitor. Make sure you don't damage it unless you have a spare, because it has to be reinstalled, because that is the connection from all of the RF power in this radio to get back there to actually get amplified. So there's the procedure. So if you own one of these and ever need to replace your driver or final transistors or MOSFETs, that's the procedure you need to use to readjust your bias current. So I hope that helps.